So suppose we have this equation, x minus 12 over all that good stuff. So the point is to multiply everything by the LCD. How does the first denominator factor? Which notice is just the other two denominators, which is good. So that happens to also be the LCD, x plus 3x minus 2. So we're going to multiply all three fractions by x plus 3x minus 2. Now, we're going to see this technique later on in Chapter 9 when we talk about partial fraction decomposition. So notice what I just did there was I took 2 seconds out of my life and I wrote that LCD next to each fraction. I am still alive. My cholesterol has not increased. This will not kill me. All right. For the first fraction, what cancels? The whole thing. What are you left with? Plus, what cancels for the next one? And you're left with plus 4. Very good. You can distribute at this stage if you want. I would wait until the next. And lastly, what cancels? And you're left with negative 2 times the quantity of x plus 3. The reason I suggest you wait is because students sometimes forget to distribute negatives through, and you don't want that to happen. What type of equation do we have now? Purple, yogurt, linear. Linear. For a linear equation, not a purple equation. For a linear equation, variable on one side, number on the other. So if you would, combine like terms, get your variable on one side, get your number on the other. So if we bring all the x's to the left, how many total x's does that make? And all the constants to the right, how many total constants does that make? So what does this say about x? Okay. So after you're done solving, you go back to make sure that that number is in the domain. Is 2 okay? Why? And also on the left, because we found this factors with a factor of x minus 2. Yep, so as long as you have at least one that causes a division by 0, then it's not good. So your answer is, there is no answer. You just write no solution, you can write that symbol. That works. Remember that symbol means does not exist. Sure. So if we put 2 back into the denominators, notice that it causes a division by 0 here and here, and we can't have that. So it's got to be in the domain.